Hello learners, welcome again. In the last sessions, we have understood how the inequalities work and we have understood a very basic method which is called the wavy curve method. Now we are going to understand more details which is more related to calculus, and that would be functions. So in this class, we'll talk more about functions as such. So functions, very basic definition is what is the basics of function? Basically an input which is resulting an output. So there should be a valid input which is called the domain, and that should give a single output which would be part of codomain. So there would be a single input giving a single output, a unique input, a valid input which is going to give you a unique output. I generally teach students this concept of functions through an example of ticketing. So, say you are going to buy a ticket on a railway window. On a railway window. Now, what will happen is basically that you'll say you are in your city and say your city name is city A, okay, and you are already in city A and you want to go to city B. Now, as soon as you go to the window and ask for city B, then what happens is the ticket generator actually collects the input and tells you the output. The output would be the ticket and the cost of the ticket, whatever dollar or rupees cost the ticket is off, right? Then if you give any other input, say city C, then that output would be quite different from the previous output. There could be another city D for which you can get the same output. For instance, say you are living in Mumbai and you want to go to, so you are already in Mumbai, okay, and you have given the input to Delhi, input of Delhi. So you are going to travel from Mumbai to Delhi, and the output came out to be rupees, say 300 rupees. Okay. Then if somebody else comes and gives an input, say Kolkata, okay, then the output will come out to be say 500 rupees. Okay. But there could be a case where say somebody said Bangalore and the output again came out to be 300 rupees itself. This is perfectly valid because two different inputs can give you a single output. 300 and 300, the same output, because two different inputs is going to give you a single output is a completely valid thing altogether. But it should be a valid input. But as soon as you say on you are on a railway station and you are saying that I want a ticket to London. Now there is no railway system from Mumbai to London, and hence this is an invalid input. And for this invalid input, there won't be any output. So input to the system or input to the function has to be valid and it has to be completely recognizable. Also, for every input, there has to be an output. There cannot be a case where you are giving an input but it is not able to give you an output. Okay, so that is the basic of function. Let me move ahead. So functions are generally dependent on independent variables and dependent variables. So independent variables is the variable which is going to take certain values, right? So x in this case, which are the independent variables in all these three equations are represented in red. So x is going to take different values. Okay, in this case, in the first case, x is going to take different values and hence x is an independent variable. Y is a dependent variable. Y is dependent on x. So x is an independent variable, y is a dependent variable. 3 and 5 in this case are constant, coefficients of x square and x respectively, and 6 is a constant. In this case, x is an independent variable, 20 is the coefficient of sin x, and y is a dependent variable. In this case, there are two independent variables x and y, and z is the dependent variable. So in this case, we are actually understanding what is a dependent and independent variables, because this is something which you are going to use a lot in the later classes, and hence I have clarified here. Moving ahead, we'll try to understand what is the meaning of a domain and a codomain. So, like the way I taught you or made you understand through the ticketing example, it is something similar which is represented here as well. Say a, this is one set and this is another set. The elements of this set, all the elements of this set should be mapped. There should not be any element which is unmapped in this set. Similarly, there could be some of the elements in this set which could be unmapped. For instance, like say a value of rupees 10,000 is never going to appear as an output. So this is perfectly valid. So 10,000 is a part of output. 10,000 is a possibility, but there is no railway station from Mumbai to whatever is not going to charge you 10,000 rupees, which is perfectly valid, right? Or say rupees 273. Say for none of the station, it comes out to be rupees 273, and this is perfectly valid. So there could be some extra elements altogether in codomain, which is fine. So 1 is getting mapped to 2, and 2 is also getting mapped to 2, which is fine. 3 is getting mapped to 3, and 4 is getting mapped to 3 again. So 1 and 4 are going to be unmapped. Each and every element in domain should be mapped. There could be few elements in codomain which are unmapped. The ones which are mapped are going to form range, and the mapped and unmapped elements together forms the codomain. So that's what I have written. This is also called in correspondence a corresponding. So a function f is a correspondence that associates with each element of A. This is an important keyword. Each element of A of a set called the domain, one and only one element B of the set, which is called codomain. Okay, and whatever is mapped, it will form the range. So domain, codomain, and range. We are very clear about it. Let's move forward. So formal definition of function: a function f is a correspondence that associates with each element of A, which is called the set. Set is called domain, to one and only one element of codomain called the range. So f of, we write it as f of A is equal to B. So if I want to write here in this case, f of 1 will come out to be equal to 2. F of 2 will also come out to be equal to 2. F of 3 will come out to be equal to 3, and f of 4 will also come out to be equal to 3. Okay, so an element A is getting mapped to element B, so we write it as f of A is equal to B to indicate that B is the value of function at A. I have already given the examples. We can also observe one very important thing. This is something which you have already done earlier in your earlier classes, but just for the sake of completion, it is very clear that if you substitute in this function fx, which is 3x square plus 5x plus 6, if you want to find out f of 2, which is x equal to 2, just replace x with 2 everywhere the way it is given. So 3 times 2 whole square, because x is 2. So 3 times 2 whole square plus 5 times 2 plus 6. And whatever value it comes out to be will be the value of the function. This is called the value of the function. This is called the input to the function. Similarly, f of minus 1. F of minus 1 is going to be equal to 4. I have just replaced x with minus 1 everywhere, wherever it was there. We can also find for what value of x fx is equal to 6. For this, we need to find out the solution of the, or zeros of the quadratic equation. This is the quadratic equation in this case, but in general, if there is any function f, we can find out, we can write fx equal to that value and whatever values of x are satisfying it will be the value of that. So it will help you in finding out the points in domain which will correspond to that value. So earlier these points were given and we were trying to find out this point. Now this point is given and you want to find out the corresponding points. There could be only just one point or there could be multiple points, that is, or there might not be any point also, right? So those kind of cases etc would be there, which is not a problem to find. So in this case what we can do is 3x square plus 5x plus 6 is equal to 6. So this and this cancels out. So I'll solve for x times 3x plus 5 is equal to 0. So x can be equal to 0 or minus 5 by 3. So for x equal to 0, fx will be equal to 6, and x equal to minus 5 by 3 also, x will be equal to, fx will be equal to 6. Also the zeros of the function is basically for what values of x, fx will come out to be equal to 0. For whatever values of x for which fx is equals to 0 will be called the zeros of the function, and graphically this represents wherever the y equal to fx function is actually getting cut by the x-axis or x-intercept of the graph of y equal to fx. We'll talk more about it in graphs etc, but that is also very basic condition. So say this is the function y equal to fx. So the points where it is cutting the x-axis, these are called the zeros of the function. So functions are generally represented as f from domain to codomain. So from this is a set to another set. So f from a to b. A is a set, b is another set, and we write the complete function as f from a to b, and fx equals to the definition of the function 3x square plus 5x plus 6 in this case. Okay, if this thing is not mentioned for a particular function, we assume it to be from R to R. The sets domain and codomain are from R to R. Basically all real numbers to all real numbers. Okay, if that is not mentioned. So we'll try to figure out how to find out the domain conditions also, but this is very clear. Also examples of some of the functions etc. So examples of some of the functions, like these are a few examples. We can find out the value of different functions also, like p of 3 will come out to be equal to, I'll write 3 of square minus 1, which will come out to be equal to 8. Okay, or f of 5 will come out to be equal to 4 divided by 5 minus 1, which is 4 by 4, which is equal to 1, and so on. We can find out other values. But very important thing, there are certain values which are not acceptable to the function also. Okay, so f of 1 for instance will result in 4 by 1 minus 1, which is invalid, because none of the functions can be divided by a 0. A number divided by 0 is invalid. Similarly in G3 would come out to be equal to 3 divided by 3 square minus 9, again, which is invalid. So denominator is becoming 0 in this case again. So such cases are invalid. Again, for say h10, so that will come out to be root over 4 minus 10 divided by 10. Now again, it is negative of a number, root of minus 6 divided by 10. Again, this is a complex number and we are talking about real functions right now. So again, this is invalid. So such situations are to be avoided, which will form the part of domain conditions of the function. So we will learn about this in the next class, but this is very important aspect to understand what are functions, what are the acceptable values, domain. All the points should be mapped to a unique point in codomain, and the points which are mapped within the codomain are going to form range, and how to find out the value of the function at different points. So that's it from my side for today's class, but we'll try to understand what is domain, codomain, and how to find out valid values of domain in the next class. So please, if you are liking these videos, you can also join our regular weekend batch, and you can drop a mail on query.infinity@gmail.com, and parallelly you can like, comment, subscribe, share, and turn on the notification button to get regular updates here. Thank you.